So I was talking to Wes a while back, and he said when we were putting together the symposium abstracts, it's like there's a lot of people talking about, and the discussion came up about energy usage in active soil depressurization systems. And he's like, Chad, you and Josh have done some presentations on this in a residential setting over the last couple of years. Have you ever done anything with multifamily stuff? Because we know there's going to be there's more and more multifamily work coming. And I said, actually, one of the buildings that we hit on last year just very quickly is a great case study for exactly what you're talking about. This building is 6 stories tall. There's, on the lower level, this is the blueprint we're seeing here, is the lower level. On the upper levels, there's 8 units instead of 6. And it's not a huge building, but just like a 75 by 75 footprint, slab on grade. There's sub-slab power and water, like water mains right underneath the slab. It's electrically heated, so electric resistance heat, not heat pumps. And Josh, there was something else we wanted to talk about. What was it?
All construction, foundation, wall, joint.
Say that again? Oh, yeah. Right, okay. When I got there, I didn't know these radon levels. This was radon testing that we did, and there was only 25% ground contact testing done, and they said we just want 6 systems on the outside of the building. Go up the outside. And I said, we don't know what we need to fix on this building, so let's test the whole building. And you can see that we have some pretty drastically different radon levels between the bottom right, I guess for you all it would be the bottom right, that's almost 70 picocuries per liter. The next one up is 2.5 or 2.4. So big difference between one unit and the next. And so as soon as we got these results back, the building owner said, wow, I didn't really believe that radon levels could be that different from one unit to the next. We're going to start testing 100% ground contact when we test, because now you have the actual data you need to be able to fix the building. Well, we ended up basically needing to fix the whole building anyway, so it didn't change the fact that we need to we need to address the entire building. But if we only ended up with one unit that had elevated radon concentrations, we don't need to focus on the entire building. We need to focus on that unit. But anyway, so this was the plan to begin with. 6 units on the outside of the 6-story building. So the question for me was, can I ever reach that center office where there's still elevated radon levels by addressing the outside? And then Josh's question is what does this cost? Right, and so we've got a couple different costs associated with this. We've got the cost of ventilation and the cost of running the radon fans. And we've got, we do some diagnostics on the building, find out that in order to reach the entire unit from the center, from the outside, we have to move about 100 CFM. I'm in central Kansas. We don't move air in radon systems. If we're moving 5 or 10 CFM in a unit this big, that's a lot of air movement for us. So moving 100 CFM, we're scratching our head going, what's wrong here? Where's that air coming from? Because it's not coming from the soil. What Josh alluded to a minute ago was we have concrete walls on the outside of the building. On the inside of those concrete walls are it's foam board insulation, about 1.5 inches or so foam board insulation. And then the slab is poured into insulation. Okay? So what we found is that foam board insulation isn't necessarily pressed up against the outside wall real tightly. And so in the foam board, or where the slab pours into the foam board, there's a big gap there. So if you drill through the outside wall underneath the slab, then you also end up drilling through the foam board, and you have this enormous air leak right by your suction point. Okay, so we've got 100 CFM moving through the system. Probably 5 of it's coming from the soil. The rest of it's coming from inside the building. So we have to take that cost into account as well when we're talking about what is the operating cost of this radon system. So, just to run the fans are actually going to operate at about 125 watts, not the 100 watts I've got written down here, at this flow rate. And so that's, instead of the $600 a year, it's really closer to $725. Okay, so that's just the cost of operating the radon fans, not the cost of the makeup air that we're having to reheat, recool. So, can we get Mentimeter to come up?
Yes.
Hey, there's Josh again.
I can hardly hear you, so I'm just kind of guessing at what you're saying.
Oh, you can't hear it. Yeah. Mentimeter? Can you pull up Mentimeter? This is my slides. Go to the website we looked at earlier. Technology's hard. Okay, so we're going to go back to the very beginning. These are the first questions we're going to ask to get to know you all a little bit. Okay, so let's go through these. Where are you from? So go to minty.com and then type in the code 30530218. It's going to ask you for a code when you get to minty.com. And we've got some people from all over the country coming in. If there's multiple people from Ohio, for example, that Ohio will get bigger. That's how this deal works. So if you want to represent your state, let us know that you're here in force. That's what we're going for. Man, it's all over the place. Come on, there's more than one Kansas for but Bruce doesn't have his phone out. Not surprised. The old guys, you know, geriatric folks in the room. Oh, my moderator says be careful. Okay, she's gonna shut me down. It should actually be a blessing. All right, this is good. We're still getting answers. I'm gonna wait for a couple more seconds here so everybody can get in. But then on the next questions we go to, we're going to move through them a little quicker because there's going to be other people. All right, click forward, go to the next question. So there's people from all over the place. That's cool. Okay, what kind of buildings do you typically work on? Your residential, commercial, or some of both? Okay, good. Interesting. Go to the next slide for me, or the next Mentimeter question. What kind of soil gas do you mitigate? Are you a radon mitigation contractor? Are you other soil vapors? Some of both? Intentionally. Yes, thank you for the clarification. It's a really good point. We were fumbling around with how to word this, possibly late last night or the night before. So this is what you get. All right, next question. Have you ever calculated the total system operating cost? And we're talking about both the operating cost of the fan and reconditioning the air. So there's a few yeses, that's good. Jesse's sitting down here, I know he has. If you've done it once, I guess you can technically say yes. That's the question. Okay. All right, now we're going to go click us forward one more time, and we're going to go back to where we were in the slides. How much do you think the added ventilation will cost the building owner? Okay, and so the added ventilation, we were moving 600 CFM with the 6 radon systems. And I'm telling you, we don't move much air. So we're going to assume that it was 500 CFM that's being moved out of the building, okay? The added ventilation in the building is 500 CFM. Electrically heated building in the middle of Kansas. How much money do you think this building owner is going to spend to operate that system? Oh, good point. Yes, a year. Over the life of the building, a lot. I wish Josh could pop in here because I'm interested to see what his thoughts are. Oh, we're hearing you now.
Hey, all right. So did you talk about who lives in this building?
Did I talk about what?
Who lives in this building?
I did not. That's a good point. So mute yourself, Josh. No, we're getting an echo.
Maybe you need to turn your mic off. Just, if your sound's coming through.
What if I turn my mic off? Everybody hear me if I turn my mic off? Can you all shut my mic? Okay. Josh could put headphones on, but does Josh have headphones to put on? Anyway, the question Josh asked was, who lives in this building? It's a multifamily building. Who lives in it? It's a subsidized, low-income building. The building owner pays the electrical costs. But the building owner pays the electrical costs. But if we install a system that increases the electrical cost to the owners significantly, where does that bill end up going? It ends up going back to the rent, which is going to end up being subsidized by us, ultimately, really is. But the thing is if these people were paying their own bills and they're low income, and we're adding, let's say, $100 to each unit for their electric bills, that could be a pair of tennis shoes those people's kids don't get. That could be food on the table that they don't get to provide for their kids. So this is real stuff. So I'm seeing 5,000s, 12,000s, big numbers, 500s. Okay, so let's get back to the presentation now. Thank you. Yeah, we skipped ahead a couple there, but this is a spreadsheet we put together that calculates the cost of added ventilation and then along with the cost of radon fans. And so what's happening here is we can type the airflow in. So we're saying that of that 600 CFM, 500 of it is added ventilation to the building. And I know this is somewhere in the ballpark, because of some other work we did in the building. We knew how much air we were moving in other parts of the building away from that air leak that we talked about. So I know that this is a realistic amount of airflow that we were moving out of the building, added ventilation, okay? So we have to know that number. You're not always going to know that number as closely as we happen to know this number. But you can make a guesstimate of what it is. If you have a lot of airflow and you're working in tight soils, I can guarantee you that a high percentage of that air is coming from inside the house, being pulled into the house and then exhausted out of your radon system. Josh, you want to take heating and cooling degree day discussion?
If you can hear me still.
Yes, we can.
So a heating degree day and a cooling degree day is actually a climate data driven, climate center data point. And each state and area in the country has a climate office where the data is kept. So heating degree day, you need to use a base temperature. Usually that base temperature is a 65-degree Fahrenheit. So for each, and then you need to know the average temperature for a given day. So they take the high temperature and the low temperature, and they average that. You put that difference to 65 degrees, and that is your assigned value of a heating degree day for that day. So for example, if it's 10 degrees outside in the middle of winter in Minneapolis, we have 55 heating degree days for that day. All right? So the colder it gets, the more heating degree days is assigned. And then inversely, if you've got, for cooling degree days, if you're above 65 for your average, it's calculated the same way. So if it's an average of 85 degrees that day, you have 20 cooling degree days. So in Salina, where you're working, you're going to have fewer heating degree days than I would here in Elko. But you would also have more cooling degree days.
Right. So
I said it right? So fewer heating degree days, more cooling degree days.
you did say that correctly. And so if we move this building to Minneapolis, and this would be really dumb to do because electrically heated in Minneapolis would be ridiculously expensive. It's ridiculously expensive in Salina, but really ridiculous in Minneapolis. Okay, so you're off again.
We read the calculations, right, for Minneapolis?
We did do the calculations for Minneapolis. We'll share those when we get done with this, but can you go back to our presentation? Okay, so Josh was talking about the heating degree days and cooling degree days. So that's 3,500 heating degree days in the middle of Kansas, where I'm from, and 1,500 cooling degree days. If you go to Miami, it's going to be more, Miami, Florida. It's going to be more cooling degree days than heating degree days because they don't have a lot of heating, right? And so, and you can find this information easily. It's easily accessible anywhere on the internet. I mean, not anywhere on the internet, but on the internet. Anywhere you can get on the internet. You can Google what's my heating degree days, what's my cooling degree days. We don't have any gas heat in this building, so we just leave this line blank for the gas heat, and same thing with cost of gas. But the efficiency of the furnace, we measure that in HSPF, heating seasonal performance factor, if I'm remembering that correctly. And 3.41 is as low as HSPF goes. That's electric heat. It's not, if you have a heat pump, it's going to be something like 10 or could be more. Air conditioner efficiency we rate in SEER, seasonal energy efficiency ratio. So that's the 13 SEER air conditioner. That's the lowest efficiency air conditioner that you could buy for a long time up until a couple years ago. Now it's 14 SEER. Cost of electricity. Cost of electricity in Salina is actually just a little bit less than 11 cents a kilowatt hour. We're really closer to 8 or 9. But we use 11 because it makes the math really easy. And also, I like easy math. It also is closer to the national average for electric costs. So we use 11 cents a kilowatt hour here. And so basically what we're doing is we're saying, how much does it cost to reheat or recool the air that you're pulling through the building? Right? We've got 500 CFM being exhausted out of the building. that 500 CFM is being brought into the building somewhere through gaps and cracks in the walls somewhere, because we've depressurized the building enough to move that air out. It's got to come back in from somewhere. And how many BTUs, how much energy does it take to reheat or recool that air? That's what this calculation does, okay? And if you are interested in this spreadsheet, I'm happy to share it with you. And if you want to look at the calculations, they're in the background in this spreadsheet. But the added cost of ventilation for this particular building per year, $2,100, okay? Fairly significant. It's a big building, but it's still fairly significant. Also, we have another $750 a year for to operate the 6 fans, the electricity for the fans, for a total of almost $3,000 a year to operate this particular radon system. Okay, so we do diagnostics, and let me go back to that slide, and you can see that we're reaching the units. We're going to fix the radon problem in the units most likely. We might fix the office, but do we want to take a chance in a big building that we're going to fix the office when we're not even getting suction under that part of the building? No, that's scary. It's like, you don't want to have a service call on a building like this. Okay, so as I'm getting into this, I'm like, this is getting worse and worse. It costs $3,000 a year to operate the system. We're not even guaranteed that we're going to fix the building. We've got to go up 6 floors on the outside of the building with a lift. And so, what is the solution to the radon problem that reduces the radon concentrations the most? Go to Minty for us. Has the lowest first costs and the lowest operating costs. So, I'll say this for Josh, since it's hard for him to come in and out of the presentation. So go to the next one for us. And this is open-ended. You can just type in whatever you want. What Josh says, if you were listening to this presentation last year, we kind of talked about it, so we're kind of gave it away last year. But what Josh says is, nobody listens to us anyway, so it doesn't matter. Burn the building, of course. That's seal, baby, seal. So sealing that air leak, it would absolutely help out with this, right? But we have to cut into the sheetrock around the entire perimeter of the building. So not impossible to do. There's people living there. So fairly expensive, fairly intrusive to do that. HRV, recovery, catastrophic fire insurance claim, yes. That would take care of the radon problem. Don't know if it's the least expensive way to make this work, but would do the trick. There was somebody that told me, I showed up to a job, oh, I know who it was, but anyway, they said I showed up to a job and they just found a burned out shell. And the people hadn't told them that their house burned down because they're in, mode. Okay, yes, so let's go back to our presentation now. You all are right, everybody that answered seal the air leak? Yeah, that's expensive though, it's a problem to do it. It's intrusive to the people that are living there, but that would help a lot. It might even allow us to get some mitigation from one unit to the next, that kind of a thing, so that we only have 4 fans on the building instead of 6, and then we may be able to reach a middle. So that is a possible solution for sure. So what I didn't tell you all was there's an abandoned trash chute in the center of the building. So I can't give it all away to begin with, right? You're laughing at me like, well, now you tell us. Okay, but there's a trash chute in the center of the building. we have access to every floor. So we can run pipe through there and strap the pipe where we need to strap it inside of an old trash chute. Kind of cool, okay? Yeah, right, yeah, so trash chute goes all the way through the roof. And so the building owner says, what would happen if we could do this? And I'm like, okay, well, we can do diagnostics from the center, but putting the suction point in the center, that's tough too, right? Like, that's where they compact the backfill the most. So let's see what kind of suction pressures we get. So this DSP1, kind of in the center of the bullseye there, that's where we put our diagnostic suction point. We connect it to a vacuum cleaner with a damper on it. We're able to measure airflows with a pitot tube. We're able to ramp the static pressure up and down. We're moving like 5 to 10 CFM on this, okay, between full static pressure or full static of the vacuum. So that was like at 55 inches of water. And at 4 inches of water, our radius of influence, you can call it, is about 15 feet. At, 20 inches of suction, we make it 20 feet. And in order to get 30 feet, so in order to double our radius of influence, we have to have 14 times more static pressure than we do to get 15 feet. So to double that, it's more than doubling the area of influence, but it's doubling the radius of influence. In order to double that, we have to have 14 times more static pressure. So is the right answer to just suck really hard on this thing? The answer is, let's put the suction where we need it, right? Because our influence is greater if we can put our suction where we need it, rather than just sucking on the soil really, really hard. There's times when you need 55 inches of suction because you just can't put suction everywhere you want it. That's stairways. So what we actually did was we came in and trenched the floor, and we did this in a day. We had like 10 guys there because there's people living there, and we don't want to have open trenches running through there. But remember I said we had water lines run right under the slab? You have to have a ground penetrating radar person come out and scope the slab before you do something like this, because it's you're going to hit something, and you could hit something that's a real problem. So what ends up happening is we trench down both hallways. We have 2 high-pressure fans on the system. We're moving about 25 CFM, and we're spending a couple $100 to operate the radon fans. And I've got to move through this a little quicker here. We're 25 CFM of airflow. We're saying that all of that's coming from the building. Probably not all of it coming from the building. But now we're at $360 a year instead of $3 grand a year for operating the system. And if we look at this over just the life of kind of a typical life expectancy of a radon fan, 10 years or so, the 10-year operational costs from the properly designed system versus the one where you just slap some fans on is 25 grand. And this is a real life scenario. We're saving these people 25 grand. And it turns out that the way that we were able to install the system actually cost a lot less than putting 6 systems on the outside of the building as well. So we have 2 fans instead of 6, so lower maintenance costs there, lower operation costs. Customers pretty happy that we were able to do this way. We've got 2 minutes left. We got slowed down a bit, so we've got some more stuff, but we're not going to get to it. So I'd say if there's any questions, go to the mic so we can hear you.
Yeah, hey, just wondered if you had any consultation with a structural engineer or something before you did it? I considered once trenching a floor, and I was told that slab is an integral structure, and if you cut it, you may compromise the integrity of the whole slab.
It's absolutely true. You have to know if it's just in this case, it's a free-floating slab. So we were able to cut into it wherever we wanted to, and it's not going to affect the structure of the building. But there's absolutely some buildings that are built with the slab as part of the structure, and you can't cut it out. Oh, Minneapolis costs? Josh, do you remember? Yeah, of course it was like double, basically.
Yeah, go ahead. What were the final radon levels?
I'm sorry, the
What were
mic
the-
went off.
What were the final radon levels?
Final radon levels were all below 1.
Thank you, gentlemen.
Thank you.
Appreciate it.